Alright, this problem is all about the radius and the Pythagorean theorem. So one thing that's special about a radius in a circle is the radius should be the same length no matter what radius you draw. So this is a radius here, it's called x. But if I drew a radius here, that should also be length x. Alright, both the red and the black are radii, and in a circle, any radius should have the same length. So I can forget about this x down here and solve for this red x up here, and that should be the same thing. So how will I solve for this red x up here? Well, obviously I put the radius here so it would form a triangle. I hinted at the Pythagorean theorem. So x here is the hypotenuse, and 9 is one of my legs, so I need this leg right here. Now, on the test, some kids try to use the 24, but I'm hoping you can see that 24 is the entire length of the chord from one side of the circle to the other. Whereas, we only want half of the chord. And we can be guaranteed that this side is exactly half because of the theorem that we've talked about. If this is a perpendicular diameter, which it is, it must be a bisector. So we know that this is split exactly in half, 12 and 12. So now we're set up to do our Pythagorean theorem. So we should have it set up like this. 9 squared plus 12 squared should equal x squared. So that's going to give us 81 plus 144 equals x squared. Adding those together, that's going to give us x squared. Alright, 81 plus 144 is 225. So that's 225. Alright, and how am I going to get x by itself? How do we unsquare things? Hopefully you said we are going to take the square root. Now normally we would have to put a plus or minus right here to show that there are two solutions to this equation, one positive and one negative. But since x represents a length, and we know that lengths cannot be negative, we'll just go with the positive version. And you probably know that the square root of 225 is 15. So that means x must be 15. So that's the answer.